All right, in this video, we're going to take a look at doing calculus techniques like derivatives, integrals, limits with polar functions. So we've seen parametric functions, and we came up with a formula for dy dx for parametric functions. And we're going to take a similar approach. Instead of x equals f of t, y equals g of t, we know that x is r cosine theta and y is r sine theta. And r itself is some function which also depends on theta. So you could rewrite each of those as r of theta, cos theta, r of theta, sine theta, meaning you have a product of functions for both x and y. Using that formula with the parametric derivatives dy dx, if I swap out that t with the theta, then this essentially gives me the formula for polar functions. The only thing I need to be careful of is when I actually find dy d theta and dx d theta, on each of those, I'm going to have to use a product rule because it's r of theta times cosine of theta for x and r of theta times sine of theta for y. So using a product rule for both of those, you get the following. If you want to swap out dr d theta with r prime, that's totally fine. It means the same thing, just different notation. And that right there is going to be our formula to find the slope of a tangent line to a graph when I have a polar function. So as a quick example, let's say I'm looking at 3 plus 3 sine theta. We should have a good idea of what the graph of that thing looks like based on our pre-calculus review. And I want to find the equation of that tangent line to 3 plus 3 sine theta when theta equals pi over 4. So take a minute, use this formula to come up with your slope. Try to figure out what the x and y coordinates are for your point slope form. Y minus y1 equals slope times x minus x1. Go ahead and pause that video and then come back and try to see if you can get the same solution that I did. And in 3, 2, 1, we're going to take a look at. Here is my working out of the slope. So I just plug right in, and I'm going to use pi over 4 each time I have a cosine theta or a sine theta. So it looks like my slope is negative root 2 minus 1. And I also need to get my x and y coordinates. So using r of theta is 3 plus 3 sine theta. I actually kind of did that in my working of the derivative, and my numerator and denominator kind of have those happening right there. Looks like I get 3 root 3 over 2 plus 3 halves. Double checking. Yeah. So those are my x and y coordinates. Plugging all of that into y minus y1 equals slope times x minus x1. The following is going to be the equation of a line tangent to 3 plus 3 sine theta whenever theta is pi over 4. So a lot of this is the same kind of stuff we did with parametric. It's just with polar, you have a lot more sines and cosines, and you need to know that unit circle. If you don't know it, you really need to know that by now. You're going to have to come up with these values on your own, and this would likely show up on a non-calculator section of any test or the AP exam. That'll actually wrap it up for this video.